Good evening to all of you and welcome to Augmintech. Hope all of you are fine and doing well. So before starting, first, all of you let me know, am I audible clearly for all of you? Yes, please. Give me reply in chat box fast. Am I audible clearly for all of you? Yes, please give me reply in chat box, please. Yeah, okay, good. So now, uh, before starting, first, we'll give you my little bit short intro. Okay. So see, myself, Mohammad Sajjad, and I am a mechanical engineer with expertise in MEP designing and modeling field. With several years of experience in industry, I have a deep understanding of the technicalities involved in MEP designing and modeling field. Okay. So I have done many lots of life project, including residential building, commercial building. We have also designed the hospitals building, malls, retail shops, and more. Okay. So that's all about me. Now, all of you know that this webinar is for external static pressure calculation. Okay. So in this webinar, we have to discuss about how to calculate the external static pressure in detail. Okay. So all of you are ready for this course? Yes, first give me reply chat box so we can start now. Before wasting time, we can start our topic. Yes, all of you are ready? Okay. So see, before starting, some announcement are there. All of you just listen carefully, okay? The announcement is that because otherwise problem is border in between the class you will ask. So I will first announce this all. Three announcement are there, okay? First of all, that we'll give you the webinar recorded access link to you. Okay. So we'll give you the access webinar recorded access link first thing. But that access link, recording access link will send you in the last in the end of the class. Okay. So this class is near about two and hours. Okay. 2 hours will take. After 2 hours, we'll complete this topic. So in the end of the class, will send the recorded access link. So if you want this link, so you have to stay with us till end of the webinar. Okay, first thing. Second announcement is I have some special offers also for you, and will also provide you the certificate of completion. But for that, what you have to do, that all I will explain you in the end of the class. Okay. So don't be just worry about that, sir, recording, we get the recording or not. Everything will give you, but that if you want that, so you have to stay with us till the end. You will get each and everything. In chat box, I will share you the link also, access link. Even I will tell you how to get the certification, means completion certificate, and some special offers also we have. So all that we'll discuss. Okay. So let's start our topic here. So as you all of you know that external static pressure is what? Why we are as a HVAC designer, we have to calculate the external static pressure. Why? The reason is what? For the for the per if you want to select the fan, any fan, either it is a exhaust fan or any fan. So here our main target, suppose if you are using in your HVAC system, if you are using air handling unit, fan coil unit, or any mechanical HVAC equipment. So inside the AHU or FCU, all of you know we have a fan, okay, to just supply the conditioner in each and every fill. In return side also, sometime in supplies, both side we have. Okay. So to find out the fan capacity, we need to submit this detail, external static pressure. But remember, we need to submit both total static pressure. Total static pressure means internal static pressure plus external static pressure. But remember, internal static pressure value you will get from the manufacturer site, HVAC unit manufacturer site. Okay. They will give you the internal static pressure. What is internal static pressure? Don't worry, I will explain you each and everything. Second, as a HVAC designer, our main target is to calculate the external static pressure. Okay. As per this, you will get the fan capacity. So that all will explain you. First, before going to discuss about the external static, first try to understand all of you that what is actually internal static pressure. As I told you now, Internal static pressure value will be given by the manufacturer side. So what is this? In short, you can see, you can say ISP. Okay. Internal static pressure is refers to the resistance of airflow caused by internal component of the HVAC unit, such as filters. If you have a dirty filters inside the AHU or FCU, okay, coils, dampers, and the casing. So internal static pressure is caused by the internal component of HVAC system. Okay. So here some example is also given like filters, coil, dampers, and casing. Clear? The manufacturer of the HVAC equipment typically provide the internal static pressure detail. Okay. So don't worry about that. To select the fan, any fan, either inside the HU, the fan is there. Okay. For the selection of fan, we need the total static pressure. So internal static pressure will be given by the manufacturer side. And this pressure affect the performance of the fan or blower inside the HVAC system. So a higher ISP require the fan to work harder to move air through the system. Okay. So this is all about the internal. Hope all of you understood. Our main target is to calculate the external. So let's see what is actually external static pressure and why we have to calculate this external static pressure. See, in short, I will explain you. So external static pressure is just, it is the resistance to airflow that occurs outside the HVAC unit. Okay. Mainly this external static pressure mainly caused by the duct work. If you are using with the help of air handling unit, if you are supplying conditioned air in multiple rooms, so via duct work. So this external static pressure is caused by the duct work, diffuser, grills, register, and other external component in the air distribution system. Okay. And the HVAC designer or engineer calculate this external static pressure based on the layout. I will show you the layout also in AutoCAD file. We have that layout. With the help of that layout, we'll show you each and everything. Okay, how to calculate the external static pressure. And this is critical. ESP is critical for selecting the fan size. As I told you in starting. Okay, higher ESP means the more power is required to move air through the ductwork, and fan must be capable of overcoming this resistance. Okay. It is given clearly here. See, someone is asking me, sir, just repeat once more. So it is, everything is given here. It is simple. External static pressure is the resistance to airflow that occurs outside the HVAC system, mainly caused by the ductwork, diffuser, grills, register, and some other external components in the air distribution system. So our main target, we have to calculate the external static pressure based on the layout. Okay. All of you clear this thing? Tell me, understood or not? How this? Tell me, please, fast. Okay. Now let's see here. I will show you the process. What is the formula to find out the fan power capacity? Here formula is there. So remember, the first step is what? First step, if you want to find out the any fan capacity, either it is a exhaust air fan or supply air fan, return air fan, whatever, or blower. If you want to find out the capacity, the first step is to determine the total static pressure. As I told you, total static pressure is what? It is the sum of the external static pressure plus internal static pressure. Okay. Total static pressure means what? It is the sum of the external static pressure plus internal static pressure. Clear? As I told you, this internal static pressure, generally this value you will get from the manufacturer side. Okay. And external static pressure, we have to calculate as a HVAC designer. So how to calculate that will explain you. So this is the first step. Remember. Okay. And it is given here. ESP is the static pressure caused by the external components such as duct, filter, grills, etc. And internal static pressure is the static pressure caused by the internal component due to dirty filters, coils, damper inside the air handling unit or FCU, fan coil unit. Okay. Understood this first step? Now, the second step, here we have a formula to find out the fan power capacity. The formula is given clearly. See, fan capacity in horsepower is equal to CFM, means airflow value in which unit? Cubic feet per minute. Okay, imperial unit. And metric unit is what? Airflow metric unit. Airflow always measure in cubic feet per meter or meter cube per second. Correct? Then multiply by total static pressure in inch of water gauge. Divide by 6356 factor into eta. Eta means efficiency. See, everything is written here. In this formula, CFM is the airflow in cubic feet per minute, and TSP is the total static pressure. If you want to find this, so first we need the internal pressure, internal static pressure value, and external. Okay, because I have already explained you that total static pressure is the sum of internal and external static pressure. Clear? And here in this formula, you can see one factor is given, 6356. It is a constant used when working with CFM and inches of water gauge. So it is, you can say, unit conversion factor is given here. And eta is the fan efficiency, which is typically between 0.6 to 0.7 for most of the fan. Okay. So these are the formula to find out the fan power capacity. So first, let me know all of you, this concept is clear. Actually, now before starting the external static pressure by using the layout, these are important things which I want to discuss with you. So first, let me know each and every step. It is clear. So simply, this is your formula in front of you. See, now the question is, maybe someone are just in your mind, the question is coming, sir, from where we get the airflow value? So remember, for airflow value, we have to do the heat load calculation. Simple. Okay. First of all, we have to perform the heat load calculation. Uh, Manually option is also there by using E20 method, or you can use the different software like HAP is one of the software, early analysis program for performing heat load calculation. Even we have a trace 700 also there. And you can go for O general method. Okay, so different methods are there for heat load calculation. So after performing the heat load, you can easily just get the CFM, supplier CFM value. Okay, is it clear? And TSP, total static pressure. So in that, internal static pressure we get from the manufacturer side. Okay, again and again I am repeating this thing. Actually, internal static pressure is generally caused by the dirty filters inside the HU, even coils. Okay, dampers are there. So due to that, the air will resist. Na? So that you will get from the manufacturer side. Our main target is to calculate the external static pressure. So when you substitute the supplier CFM value and external plus internal static, you will get the fan power. Okay, fan power capacity easily. Now, the next step is what? Sometime what happen? If the fan capacity, suppose, let's say, if you want to find out the airflow rate in case of exhaust fan selection, for example, for AHU, okay, you can do the heat load calculation, and from there you will get the supplier CFM value, everything, even the cooling load value also. But let's say if you have any exhaust fan, let's say, for example, in toilet, if you are giving toilet ventilation, okay, in kitchen, you are providing the ventilation. So in toilet, generally, we are giving ventilation. Two types of ventilation are there, all of you know, natural and mechanical. Okay. So mechanical, generally, if it is a large commercial toilet area, so with the help of ductwork, we are extracting bad odor from each and every toilet. Okay. So here, in this case also, we need to just do the selection of exhaust fan. So from where you will get this capacity, airflow value. So for that, here the formula is given. See, it is given in some cases, if you are determining the required fan airflow capacity, you need to calculate the required CFM value. Okay, for this space or system. So the formula is simple. Airflow is in cubic feet per minute is equal to volume of that space into, remember, volume which we have to calculate of that space in cubic feet, correct? Into air changes per hours, divide by 60. So in this formula, volume of space from where we get, easily from the layout, you can easily calculate the volume of space in cubic feet. Okay, remember this thing. Air changes value, here AC air changes per hour means what? In 1 hour, how many times we have to change the air to maintain the comfort environment. So this value you will get from the ASHRAE ventilation standard 62.1. Everything you will get from there. Okay. Our main target, I'm not talking about the ventilation. Okay. This all in ventilation we are teaching. Okay. So ACH is the number of air changes per hour required for the space. Suppose let's say if it is a toilet area, so how many times we have to change the air, that all detail is given in ASHRAE ventilation standard 62.1. Okay. So you will get each. Suppose let's say if it is a kitchen area, so how many times we have to change the air, that all detail is given. Okay. As per your space. Clear this thing? Tell me please. All of you let me know. Is it clear this thing? Anyone have doubt? So please let me know fast. Okay. These are the basic thing which you have to know before starting the calculation. Next thing here, let's say I will show you one example. So you will get the idea here. How? Suppose for example, if you have a external, suppose you have done the calculation from the layout, you have calculated the external static pressure value in water gauge. How much? In inch of water gauge is suppose 1.5. Okay. And internal static pressure you will get from the manufacturer side is 0.5 inch of water gauge. So now to calculate the total static pressure, what we have to do? Internal plus external. And airflow value, suppose you have got from the heat load calculation 3000 CFM. Okay. Fan efficiency, as I told you, for most of the fan efficiency, we have to take between 60 to 70%. Okay. Here I have taken 0.65. So when you substitute this all value in this formula, so how much we have got? See the fan power capacity, 1.45 horsepower. Simple. This is our main target. Okay. For the fan selection, generally, we have to do the external static pressure calculation. Clear? So hope all of you up to here, all of you understood what is our criteria. Okay. How you will get the fan capacity and everything, and why we are calculating the external static pressure. Clear? Now here some formula is there. Suppose let's say if you are just if you want to calculate, suppose let's say if you want to calculate the external static, as I told you now, external static pressure caused by the duct work. So let's say if you have a longest duct routine and you are performing you're calculating the external static pressure. So if it is a straight duct, if it is a straight duct, so for that here formula is given to calculate the friction loss or pressure loss value in a straight duct. Here one formula is given. Okay. What is the formula which you have to use? Delta P means friction pressure loss. Delta P is equal to 0.109136 into Q to the power 1.9 divided by DE to the power 5.02. So what is this? See all of you. In this formula, delta P is what? Frictional pressure loss in inch of water gauge per 100 feet of duct length. Remember, Q is what? Q is the airflow in which unit? Cubic feet per minute. And DE is the equivalent diameter of the duct in inches. Correct? So if you want to find out the pressure loss or friction loss value in a straight duct, so remember, at every 100 feet of duct length, if you want to find out the frictional pressure loss value, so you have to use this formula. Correct? By using this formula, you will get the pressure loss value easily. If you know the flow value, suppose if you have a main duct, okay, from the main duct, suppose the supply air CFM from the HU, you are supplying 1000 CFM air. Masroor Ahmed, do not write anything in the screen. Okay. Please just erase this. See, if you want to find out the pressure loss value in a straight duct, so by using this formula, you will easily get, because I have told you this Q value you will get from, suppose from the HU, you have done the heat load calculation. Okay. Now from the HU, you are supplying 2000 CFM air. Okay. In the main duct, first of all. So Q value you will get easily. Then diameter, this equivalent diameter. Remember, if you are using rectangular duct, for example, in your case, if you are going for rectangular duct, but here to calculate the pressure loss value, we need the equivalent diameter. So first of all, you have to change that rectangular duct into round duct. Okay, and calculate the equivalent diameter. What is the formula that I will explain you? Even we have a MacWay duct sizer software. With the help of that software also, you can easily get the diameter. Okay, each and everything I will discuss. So don't worry about that. Just here I am showing the formula. So you have to remember this formula. Okay, in a straight duct, what formula we have to use? This one, correct? Is it clear? Tell me, please. Okay. And here the factor is the empirical constant derived from experiment and standard duct friction calculation. Okay. Now come to next one. Now let's say, suppose if you are calculating the external static for duct work. So let's say if any fittings is coming like elbow, and if suppose transition reducer is coming. So how you will calculate the external static pressure in elbow or reducer, or let's say if it is a diffuser grill, because I have told you now, external static pressure caused by the ductwork, diffuser, grills. So for that, again here, when you see the formula is given, and as I told you, how to convert the rectangular duct in equivalent diameter, simple. For non-circular duct, for example, rectangular duct in your project, suppose you are using rectangular duct. So you would use the equivalent diameter, which account for the shape of duct. So to calculate the equivalent diameter, simple, here we have a formula. 1.3 into AB to the power 0.625 divided by A plus B to the power 0.25. It means what? DE is what? Equivalent diameter in inches. A is the width of the rectangular duct in inches. And B is the height of rectangular duct. Correct? So let's see just example. Here I will show you one example so you will get the idea. For example, let's say in your project you are using, because most of the case we are going for rectangular duct. Okay? Because in above the false ceiling, we do not have that much of a space to run other type of duct. So in rectangular duct, you can easily, by reducing the height of the duct, you can, and increasing the, you can easily increase the width of duct. So let's see, for example, in rectangular duct, suppose the width of rectangular duct is anything 24 inch. Okay. And the height of rectangular, suppose above the false ceiling, the height is available for to run the HVAC duct work is suppose 10 inch. Just let's say. So if I told you, just convert it into equivalent diameter. So formula is what? As I told you, A is what? Small a in this formula is the width of the rectangular duct, and B is height. So when you substitute, see, DE is equal to 1.3, simple. Okay. Now 24 into 10 to the power 0.625, then divide by what? A is 24, B 10 to the power 0.25. So can anyone tell me the value, how much we have got for this case? Equivalent diameter. Please just take the calculator in your hand and let me know, please. Just fast, all of you, do the calculation. Don't be keep quiet, okay? Just let me know in chat box how much value we have got here. Fast, please. Anyone have calculated? Yes, anyone from this all what I am showing now, this all from the SMACNA standard, okay? Muhammad Abbas. In SMACNA, you will get each and everything. Don't worry this. Tell me fast, all of you, how much value we are getting here. So near about, I think 16.5 as per my calculation. Okay. So whatever the value is coming, that is your equivalent diameter. Now, this you have to submit into the formula, simple. Okay. So I have an Excel sheet. In that sheet, I will explain you in detail. Okay. This is the manual because you have to know the manual calculation also. Okay. Now, suppose how you will calculate the losses due to fitting, any fitting, like if it is a, suppose elbow is coming or reducer, transition, any fittings, shoe neck. So how to calculate the losses due to fitting? So here again, one formula is given. APK is equal to C into PV. What is this C? APK is, as I told you, losses due to fitting. PV in this formula is velocity pressure and C is the pressure loss coefficient for fitting. From where you will get? So for that we have a software. Okay. HVAC duct data fitting software is given. Okay. With the help of that software, we can easily calculate that. We'll discuss that thing. Here, just remember this formula. Okay. C into PV. Now the question is velocity pressure. So same for the velocity pressure also we have a formula to calculate the velocity pressure. Formula is what? V by 4005 to square of V by 4005 in inch of water gauge. Okay. V is the velocity of airflow. How much velocity? That all we get from it. Okay. Is it clear this thing? Tell me up to here anyone have doubt? Please let me know so we can go further. From where you will get the duct velocity? It is very simple. All of you know the discharge flow rate formula. Q is equal to AV. Okay. In this formula, Q is what? Airflow rate. Correct? Airflow. Suppose. And A is the area. Area of that duct. V is the velocity. So if you want to calculate the velocity, suppose. So V is equal to Q upon A. And we know that Q already we get from the heat load calculation, and area of duct is what? Suppose let's say if you are using circular duct, so area of circle pi by 4 d square. Simple. You will get the value of V. That all. It is very easy. Okay. So I will show you in Excel. So it is, you will get the idea about each and everything. Okay. So to calculate the losses due to fitting, you have to use this formula. Simple. And here see, the turning vents and splitter vents is given. What is turning vent? Why we are using this turning vents in ducting? Turning vents are used to reduce air pressure loss. Simply. Splitter vent. Basically, for what purpose we are using splitter in elbow? Yes. Fast. Let me know all of you. Hi, yeah, of course. Everything you will get from the software or manually also. Okay. Tell me fast. About recording, I have already discussed. All of you know that. We'll provide you the recording, but we'll give you the webinar recording access link in your chat box in the end of the webinar. Okay. So for that, you have to stay with us. So you will get each and everything. To reduce the friction, simple. We are using a splitter here. Now, how many number of splitter we have to use in elbow, duct elbow? So it is depends on the width of the elbow. Can you see here? Depends on the width of the elbow, you will get the number of splitter. So it is given here, detail. If your suppose duct width is up to 500 mm, so number of splitter 1 is enough. If your duct width is more than 500 mm, so number of splitter is 2. And if it is more than 1000 mm, so 3 splitter. Okay, remember the selection of a splitter is given as in SMACNA like this. Okay, to reduce the frictional, generally we are using splitter. So now let's come to our topic now. So first of all, here, just search it. Yeah, in career also you will get this detail. So same, here I have taken one Excel sheet. Can you see this Excel sheet? In that, I have also applied the formula and everything. See, width. First of all, here the different supply. If you are calculating this, suppose supply side, for supply side you want to calculate, because in HU we are using blower or fan in supply side. In some HU you have seen in the both side. In for return air also we are using fan. Okay, forcefully we are extracting that return air also from each and every space. So that, so here it is given. Suppose the width. Suppose for example, if you want to calculate the friction loss value in a straight duct. So simple, first we need, you want to enter the width of duct in mm. Automatically you will get the duct width in inches, because here I have applied the formula. Simple. Now enter the duct height. Even for equivalent diameter, see the formula we have applied here. Can you see? To find out the equivalent diameter, what is the formula which I have shown in the image in a PPT? 1.3. See, D into means same width of duct into height to the power 0.625 divide by A plus B means width plus height of duct to the power 0.25. So same formula I have shown in PPT. So to find out the equivalent diameter, same formula I am using here. Sometime, for example, in your case, because in our case, we are using rectangular duct. So first we have to convert the rectangular duct into equivalent diameter. So same, by using this formula, we can do. Now same, if you get the area, so you will get the, equivalent diameter if you have calculated. So you can easily calculate the area of duct. Okay, so same pi by 4, same formula I have, which I have shown you here now. Pi by 4, pi value is written 3.14 into G10 divide by 10. G10 is what here? Yes, means diameter, correct? So same formula is there. Here you have to enter the length of the duct in meter, duct velocity. Finally, if you know the area and diameter, we can easily calculate the duct velocity by using the formula Q is. And if you know the flow value, so Q upon area is your duct velocity. So same, I have written here formula. And velocity pressure formula is written V upon 4005, square of 4005. Okay, so this all formula first I have discussed with you in PPT. And finally, the loss, if you want to calculate the friction loss value in fitting, so we need the loss coefficient, but this value you will get from the software. Okay, now here you have to enter the airflow value, then frictional loss value you will get. In 100 feet of duct length, how much friction loss in inch of water gauge? Here you will get that value. If you want to calculate the actual width, so you have to multiply this value to the actual length. Okay, finally you will get the total static, external static pressure. So is it clear? Now which layout we have to use to calculate the external? Here I will show you one simple layout. Can you see this layout in AutoCAD file? All of you just give me reply fast. Don't be keep quiet. Please be active. Okay. Here I have taken one small, just one ground floor commercial project. It is okay. You can see this is our entrance, main entrance. So from here you have to entrance hall is given. Okay. Here staircase, different room like office, or this also office 1, office 2. Okay. So what we are doing, and see the chillers, AHU and everything is above the terrace. Can you see? Here we have placed 2 chiller, one working, one is standby. Same way, primary pump, secondary pump is shown 2 working, one is standby. Okay. So here generally we are using a air cooled chiller. If you are, suppose, let's say, if you are selecting water cooled chiller, so you need to place the cooling tower, condenser water pump. So for air cooled chiller, only primary and secondary pump. All of you know, primary pump is responsible for what? Yes, primary pump is responsible to supply the water from AHU, from any mechanical equipment to chiller. And secondary pump is responsible to supply the water from the chiller to each and every equipment. Correct? And see here, whatever line you can see, this green line is our chill water supply line and red color is our chill water return line. Even each and everything is, you can see here. So here what we have done, see some FAHU also we are using, even ground floor FAHU, first floor FAHU. And this is our ground floor AHU, air handling unit, let's say. See, the supplier here you can see inside the AHU we have a fan. Na? So to find out the capacity of this fan, we need to calculate the external static pressure. Okay. An external static pressure caused by the ductwork, diffuser, grills, registers. So that we have to perform. So this is your supply air duct. From the terrace, this is our supply air duct routine. And from this OTS, open to sky, we are taking the duct down. And you can see now in ground floor. Now, with the help of this ductwork, supply air duct, we are supplying conditioned air in each and every space. Can you see? Yeah, of course. Yes, you are right. Actually, now remember, we have a different system. Muhammad Abdul Hafiz, we have a different system. Okay. In chiller, sometime we are using VFD. VFD secondary pump is generally connected with the variable frequency drive. You can easily regulate the speed of that fan. So different topics are there. Okay. It is we are not having that much of time to discuss about chiller system. So just leave it right now. Just and see. Is it clear this thing now? Layout is clear. Tell me fast. So here we'll take one of the layout and see FCU also we are using. Suppose for example for court for detention area. This is our police building actually. Here we are using separate FCU in this area. Same with chill water supply, return air, everything is there. And one FCU we are using here, which we have placed above the false ceiling. Remember, even see we are using the hanger also. Above the false ceiling, we have to place the FCU. With the help of this FCU, see, via ductwork, we are supplying condition air in this control room. Even this our waiting room also, we are supplying condition air, and this room, deputy office. Okay. See, this green color is our supply air, supply ceiling diffuser, and red color is return ceiling diffuser. Correct. Here we are using flexible duct also to connect to the diffuser. It is depend on you, depends on the requirement. Sometimes we are not using flexible duct, directly we are connecting the duct. Okay. And the duct which we are using here is rectangular duct. Okay. So what I am doing, suppose let's say I'm just considering this routine because this is this small and small routine. So go for this. Here the elbow is also coming reducer even. So always remember, if you are calculating the external static pressure in duct work, so always we have to select the longest duct routing. Okay, don't need to go for the branch duct like this. See here we have taken one branch duct and we are supplying condition air in deputy office. Same way here also when you see one branch duct, with the help of this duct we are supplying condition air in waiting. Okay. So remember, to find out the external static pressure, always we have to select the longest duct routing. So can you tell me, suppose this is FCU, inside the FCU, the fan is there. For the selection of that fan, I am just doing the calculation. So all of you tell me, in this duct routing, which is our longest duct? Only you have to consider this duct. See, this is our longest duct routing up to this diffuser. Can you see? So just consider, because problem is what now? Remember, if suppose your fan is capable to supply the condition air into this farthest room or farthest air terminal, so it is easily supply the condition air in this branch duct also. Okay. So that is why if you want to calculate the external static pressure, always we have to select the longest duct route. Okay. Now let's say now we are going to start from here. Suppose this is our FCU fan coil unit, their capacity is written. So first of all, when you see your flexible connection, always 500 length, generally the total length of this flexible connector. Generally, we have to place in the starting of the unit. For what purpose? To prevent the vibration. Na? Because here we have a fan inside FCU, and when you are supplying condition air forcefully in this duct, so maybe the vibration. So to prevent the vibration in its starting, we have to give the flexible connection. Okay. So whatever their length, you can just measure it with the help of DLI command, dimension linear command. From this point to this point, you can easily measure. See, the total length of this flexible connector is 150 mm. Okay. Here remember, each and every value is in millimeter because here we are working in millimeter. Clear? And what is the width of this flexible connector? Opening from this point to this point, see, it is 1100. Okay. Clear? That all I will explain you. Don't worry. Yeah. Someone is asking me, Abra, don't worry about that, about YPs and everything. That all, it is not there in this uh, routine, but I will show you in software. Okay. How you will get. So see, here the flexible duct width is 1100. Suppose the height, I am assuming height of duct is how much here? 300. So just take the height of this flexible connection, 300. Okay. Width 1100, height 300. And total length of this flexible connector, I have already shown you 150. Now, if you want to calculate the friction loss value in this flexible connection, so what we have to do? Tell me, please. Simple, just open the Excel sheet and let's see all of you. Please try to understand. No need. Here we do not need any isometric. Directly from floor plan view, you will easily get. See, here in the supply, because we are calculating the external for supply side, okay? Just write down supply side in description and I have written flexible connection. So let me know what we have to do first. How much width of flexible connector? 1100. So I have written here. Height of flexible connector is 300 mm. So just write down. And the length we have seen 150 millimeter. So in meter, how much? 150. Correct. So I have near about 0.2. Okay. So as per that, you will get the velocity pressure value, see, and duct velocity also 2326 FPM, sorry, feet per minute. Here for the flexible connection, yeah, flexible converse connection, both are same. Okay, Sevni, that only I am talking about. So loss coefficient can, we have to calculate the loss coefficient? No, because remember it is a straight, na? In a straight duct, either it is a flexible or whatever type, we have to use same formula to find out the friction loss value. Formula is what? 0.109. See, I will show you here. It is given here, clearly written. Can you see? Formula 0.109136 into Q to the power 1.9 divided by what? Equivalent dia DE to the power 5.02. Same formula. So when you see here, everything is written. Now you have to enter the CFM value. So can you tell me from the FCU, how much air we are supplying? Total air. So it is given. See, in text, it is written. SAD means supply air duct size is given, 400 width and 300 height. Always the larger size will be width. Okay. And at the rate of 781 CFM. 780 means main duct CFM is 781. Correct. So write down CFM value, cubic feet per airflow value. We have got 781. I have written here. Correct. As per that, when you see in 100 feet of duct length, how much friction loss we have got? Tell me, please. Because the formula which I have shown you to find out the friction loss value by using this formula in 100 feet of duct length. So see, in 100 feet of duct length, the friction loss value in inch of water gauge is 0.004. But if you want your total length of this connection is what? Canvas connection, 0.2 meter. So for that, how much? Tell me. Tell me. Yes. Our total length is 0.49 something, na feet. So it is near about 0.000. That is why it is not visible. Okay, if you want to see how much, just see, I will show you. Near about 0.4022 inch of water gauge. Is it clear? But remember, always, all of you remember, always in the flexible duct or canvas or flexible connection, the losses should always be 2 times greater than normal duct. Suppose if you have a straight normal duct and you have calculated the friction loss value. But in flexible connection of flexible duct, the losses should be 2 times greater than what you have calculated in the normal duct. So here in remark, I have just multiplied by 2. See, the value which we have got, just multiply by 2, whatever. Now just hit on that. How much we have got here? 0.00044 inch of water gauge. Okay, that much of losses. Is it clear, all of you? Tell me, please. The first point is clear here. Tell me fast. Give me answer. Don't be keep quiet. Please give me answer fast. Okay. Now come to next one, all of you. Next what? After this canvas or flexible connection, can you tell me the next is what? You can see here we have one reducer because our duct size as per McVay duct sizer software, we have calculated this size. We have got as per this 781 CFM, the size which we have got from the software is 400 by 300. Okay. Actually, we'll also make one webinar on duct designing method. Okay. How to design the duct, how to size the duct, that also we'll plan to take one webinar on duct designing method or duct sizing method. So tell me fast, all of you, who are interested for this webinar on this topic, duct sizing method. All of you know that we have a three methods of duct sizing, na? Equal friction method, velocity reduction method, static regain method. So we'll plan to conduct one webinar on this topic. So who are interested, just give me message in chat box. Mujib, don't write anything, otherwise I will remove you from the group. Okay, just erase this all line. So tell me now, who are interested for this webinar. Can we conduct webinar on duct designing method? Okay. Okay. Okay, so we'll plan the next, okay, on duct designing method. So let's see first this one. So see, from the McVeigh duct sizer, we have a different method of duct sizing. In most of the cases for residential or commercial building, if it is a residential or commercial application, generally we are using equal friction method. Okay. And if it is a where suppose for that application where cost is not an issue, for example, if you are designing for a duplex apartment, okay, palace, in that you are doing the duct sizing, so better is to go for velocity reduction method. Okay, the cost, if you compare both equal friction and velocity reduction, so the cost of velocity reduction method is high as compared to equal friction, but here the sound, the noise is less. So that is why I'm telling, if in that area where the cost is not an issue, like palace, duplex apartment, deluxe apartment, okay, so you can go for velocity reduction method for duct sizing. For commercial or industrial, we are generally using equal friction method, and for industrial application, we are going for static regain method. Okay, is it clear this thing? Tell me please, why do you the velocity maintain 650? Where we have maintained Sydney 650? Where the velocity is 650, you have seen. From the formula, each and from the software also, each and everything you will get. Okay, so don't worry about that. Hi, yeah, of course, Sanjit, you will get the recording access link, but that link will share in the end of the class. Okay, again and again I have repeated. Now come to start our topic. Let's see. Now after this canvas, this flexible connection, when you see now the reducer is coming, na? Because the opening of this machine equipment is, the width of opening is 1100. So the duct size we have got 400. So here we have to place the reducer, correct? Is it clear? So now to find out the friction loss value in reducer, this is one type of fitting only, na? Transition. So what formula we have to use? Tell me fast. What formula we have to use? I have explained you C into PV. C is what? Loss coefficient value, and PV is the velocity pressure, correct? And C value, loss coefficient value, you will get from the software. Okay, here I have ASHRAE duct fitting database software. I will explain you. See, first let me know what is the larger, before reducing, what is the width and height of this duct? 1100 and height is 300, correct? After reducing, the width of duct is 400 and height also same, 300. So first of all, now come here in the Excel sheet and write down reducer. Before reducing, the width of duct is 1100, height is 300. After reducing, the duct width is 400 mm and height 300 mm. Okay, I have entered it. Now anything else which you know? Yeah, we also know the length of this reducer. So just measure the length and let me know by using DLI command, shortcut DLI enter, dimension linear command. Okay, DLI enter. From this point to this point, see how much it is showing, 450 mm. Total length of this reducer or transition is 450 mm. So write down here in mm 450. So in meter, how much? 0.45, correct? I have written. As per that, you will get the duct velocity. Even velocity pressure value is also we have got, because formula is what to find out the velocity pressure. PV is equal to square of V by 4005. So velocity already we have got here. So when you divide this 1568 value, 4005 square of this, you will get near about 0.1534 value. Okay. Clear this thing? Now, the next one is this is one type of fitting. So here we don't need to use that formula which I have shown you in a straight duct. If it is a straight duct, so on that time you have to use, to calculate the friction loss value, you have to use that formula 0.109136, whatever I have shown. But if it is a fitting, elbow or reducer or shoe neck or any type, other type of fitting, and you want to calculate the friction loss value, so what formula you have to use? Let me know. Yes. See, I'm just showing you. I'm sharing this screen here. I have say discuss about this. C into PV, velocity pressure into loss coefficient value. So now the question is here, sir, from where we get the loss coefficient value? Directly also you can calculate with the help of software. Okay. See, so for that you have to open the duct. See, S-ray duct fitting database software. Can you see this software? Let me know, all of you. Software is visible. S-ray duct fitting database software is visible. Okay. So you can also get the directly in the software, directly you will get the value. Okay. Otherwise, you can use formula, both same value you will get. So let's see. Here we have a transition, correct? And we need to find out the loss coefficient value in transition or in reducer. So simply see, here we have a different option: supply, common, exhaust. So come here in the common, and we are talking about rectangular. So hit on this rectangular, and here you can see straight duct option is given. Suppose, let's say you want to find out the friction loss value in a straight duct. That all I will explain you. First come here. Our main target is what? See, in supply, hit on this rectangular duct, and now you will get one option, transition. Okay. Hit on this plus sign and pyramidal. Can you see this? Just right click, view full screen. See, this is your transition. Na? Same like this only. So to find out the loss coefficient or friction loss value in this transition, some detail we have to enter, like the width of the, suppose before reducing, what is the width of your duct? It is shown is W naught, height H naught. After reducing, the width of duct is shown here W1, height H1. Okay. So, okay, just close it, and that value here we have to input that value. So can you tell me in our case, can you tell me what is our W naught value in inches? Okay, remember here the value which we have to enter in inches. So in our case, when you see, this is our reducer. So before reducing, what is the width of duct? Tell me fast. Sorry. Width of duct is what? 1100. I have shown you. Okay, see DLI command, use this DLI command from this point to this point is 1100, correct? And height is same 300, let's say. Okay. And after reducing, the duct width is 400 by 300 mm. Is it clear? So can you tell me the value in inches? So this W naught is what? Before reducing the duct width, 1100 mm. So when you convert this 1100 in inches, you have to divide by 25, na? So you will get near about 44 inches. And height is 300. So in inches, how much? 1 inch is equal to how much mm? 1 mm is equal to how much inch? Yes, fast. Yes, of course. 12 inch, correct? 300 mm means 12 inch. So I have written 12 inch. Now tell me the value, height of duct. After reducing, what is the height of duct? 300, 12 inch only. And width is 400, means 16 inch, correct? Now you have to enter the length of that reducer. You see in the figure, it is given everything, okay? So you have to just see this figure, as per that, the value you have to enter. What is the length? We have entered already in Excel sheet. I have shown you 450 mm near about, na? So 450 mm means how much in inches? So divide by 25 by 4, you will get 18 inch. Yeah, near about 18 inch. Just enter the value 18 inch. And flow value is how much? So you can see the flow value, airflow value is 781, correct? CFM. So write down the flow value here, 781. And remember the unit here in bracket, the unit is given CFM. After entering this value, after enter this all value, you have to hit on this calculate. So now you will get the value. See, each and everything directly they have given, the software will directly give you the pressure loss value in inch of water gauge. How much? 0.01. Even directly you can, if you want to substitute directly, you can just substitute. Okay. Otherwise, by using that formula, C into velocity pressure. So loss coefficient value. So what is the loss coefficient value we have got here? Because this is after reducing the width is W1 H1. So you have to see the C1 value. 0.61. Can you see the loss coefficient value? So this value, you have to come here in the Excel sheet and write down 0.61. So now as per that, see, you will get the value. But this value is correct. Tell me. First, let's see. It is coming. See, the formula is same, na? I think the formula is correct or not. 1 minute, for reducer. See, formula is whatever to calculate the friction loss value. Formula I have told you. C into velocity pressure value, na? So actually here the formula is not correct. So apply the formula is equal to, where is velocity pressure value? Sorry, 1 minute, just go back. How much we are getting here? P7 into J7. Okay, P7 into J7. Even see here it is showing everything. Velocity pressure at V0 is 0.0 something, and velocity pressure at V1 is this one. So that also you will get easily from here. Even the velocity is also given. So that all. Directly also you can write down. Otherwise, see, here the formula is not correct. So you have to apply. So which velocity pressure we have to consider from here? Actually, we are getting two velocity pressure. Na? So this V1 from here, remember, okay? Because we are calculating this, V1 you have to consider. Velocity pressure at V1 0.02. How much we have got? Tell me. Always just go for largest one, okay? So now I am applying the formula here. For reducer also, see. Same formula I am just going. All of you listen carefully, okay? What formula we are using here. So let me know, please. Or otherwise, directly you can enter, okay? If you want formula, but actually I want to check it. Just 1 minute, 0.61 into velocity pressure, 0.745. 0.61 into 0.1534.09. Okay, here the value is coming P7. Just wait, P7 it is showing into J7. It's not correct. So here you have to let me from the software how much we have got. Yes, anyone? Yeah, I know that. Actually, I want to write down directly. Okay, just go for directly. Here it is given. So see the pressure loss values directly they have given. So why you are doing using the calculation? If software is available, so if it is not there, so on that time we have to go 0.01. It is showing na inch of water rate. So just write down directly here. I am writing 0.01. Okay, clear this thing. Now same way, if next after that when you see na. When you see here, next after reducer, when you see, then we have a straight duct. Now you have to calculate the friction loss value in a straight duct. So simply by using the formula also you can go. Otherwise, see, you can enter by software also. They will get you will get the value directly. So first let me know what is the size of this straight duct. 400 by 300 correct? And total length of straight duct is what? So by using DLI command, I am just measuring is 3713 means near about 4 meter or 3.7 meter, correct? Now what I am doing, just open your software, HVAC duct fitting database software. Here, if you want to find out the pressure loss value in a straight duct, so simply what you have to do, come here in the common option. In common, see rectangular straight duct option is given. Select it. Now, here you will get the reference H width, flow, and total length. These are the detail which we need. So enter this. What is the height of our duct? 300 You know that straight duct height is 300. So means 12-inch. And width is 400, means 16-inch. Now they will ask you about absolute roughness value. So absolute roughness value, actually here I am taking as whatever default value. Actually this value you will get based on the duct material, which type of material you are using. As per that you will get the value. Okay, so take the default value from here. And the length of our total duct is how much? Tell me fast, all of you. What is total length of duct? 3.7 meter. Is it clear? So here I am writing 3 point, sorry, in meter, na? Here we have to enter the value in feet. Sorry. So tell me in feet how much? In Excel sheet I have written. In feet, what is our straight duct length? If suppose in meter it is 3.7, so just multiply by 3.28. 3.7 into 3.28, you will get near about 12.1. No, I don't want the length in inches. Actually, see in this software, the length you have to enter in feet. 12 point something. Just write down 12. And flow value is how much? Same, 781, correct? So I have written here 781. Hit on calculate. Now you will get the pressure loss value. See, 0.00 something. Here it is not showing. And so by using this, this also you will get. Otherwise, see, if you want to see, so first of all, actually, I think near about 0.00 something it is coming. That is why it is not showing. No problem. I will show you in Excel sheet. See, here also manual calculation when you do. Tell me the width 400, height 300. Okay, and the length of duct is 3.7 meter. Correct? As per that 12.14 we have got. Correct? Now velocity, pressure, everything. Now you have to enter the flow value 781. And remember, why in the previous when we are calculating the reducer friction law, it is showing so high? Because here I have not changed the flow value, na? That is why. Just change the flow value here also. So same value you will get, okay? In manual calculation by using formula, or so here I have entered directly. If you go for formula, so same value you will get. Okay, so don't worry about that. So see how much we are getting here friction loss in 100 feet of duct length. Friction loss is showing. Tell me please. 0.045. But our total duct length is 12.14 feet. So if for 100 feet of duct length, friction loss is 0.045. So in for 12.14 feet of duct length, how much? You have to do the cross multiplications. Formula is apply here. So 0.0054. Actual value, the friction loss which we have got for actual length of duct is 0.0054. Correct? Is it clear? Same way when you see in software, we get same value, but here they are not showing because they have only shown the value after decimal. 2 value is given here. Okay, and our result is coming 0.0054 later. So, okay, so that is why they have not given. So, okay, is it clear now? Tell me please. Actually, in our duct, na, the friction loss is very small. low. So that is why it is not so, because CFM is low, na, 781 CFM. If you increase the CFM, na, let's say for example, 2000 I am taking. So see, then they will give you the value 0.02 for 200, but in our case 781 CFM we have. Okay. So it is so small, so it is not giving. So don't worry about that. So in this way, directly also you will get even by using that source formula which I have shown you. Now come to our next. Now let me know, we have completed the friction loss for straight duct. After that, when you see, again we have a reducer. See, what is the length of this reducer? 450 only mm. And before reducing, the size is 400 by 300. After reducing, the size is 300 by 300 mm. Okay, remember this side. Now I want to find out the pressure loss value in reducer. So simply come here in supply transition pyramidal and enter the value. Before reducing, what is the width? Width is 400, means 16 inch. Correct? Am I right? Tell me, please. And height of that duct is 300, means 12 inch. Correct? After reducing, when you see in AutoCAD file, after reducing the duct, the height and width is 300 by 300. Flow is also, see, different. Before reducing, the flow is different, 781. After reducing, when you see na, the flow value, because you are supplying some amount of air here, na, so automatically the flow will reduce 489. Remember this concept. So first of all, here 300, now after reducing, the size is 300, width also 300, so 12 inch, and the length is 450. 450 means how much in, tell me, in inches? 18 inch, correct? So I have written. And now the question is, sir, what flow we have to enter? So always remember, always you have to enter the previous flow, okay? Whichever is greater, 781, na? That value you have to enter here. Just enter the 781. As per that, hit on calculate. See now, the pressure loss value is showing 0.01 and loss coefficient 0.14. Okay. So now we'll show you in Excel sheet. Yeah, just write down 400 by 300, 300 by 300. Okay, after reducing this width and height is 300 by 300, correct? Total length of reducer is 4 pi, means 0.45 meter. Is it clear? And friction loss value, when you see na, no, why we have not put C? Here we have done na, in straight duct, why we have not put C? 781 we have taken na, in Excel sheet. See? Come here and let me know, please, all of you. Before reducing, what is our flow value? Whatever 781. After reducing, when you see na, in AutoCAD file, the value is 489. Okay. So just enter that value here. Actually, we don't need here flow at 489. In fitting, to calculate the friction, we have a formula, all of you know. Formula is what? See, it is given here in reducer. Can you see the formula? M11 into L12 means M11 means loss coefficient value into velocity pressure value. Okay. So loss coefficient, how much we have got? Tell me in our case. Yes. Fast. Tell me. Here in software, we have got na loss coefficient value 0.14. Just enter that in Excel sheet and check it. 0.14, I think. Na? So as per that, when you see here, we have got the value 0.0025. See the value we have got 00. As per formula, we have got the friction loss value 0.0025. But when you see in software, the loss we have got friction loss value 0.001. So maybe the problem is what now here, why we are getting, because in this formula we have written, okay, loss coefficient into velocity pressure. Velocity pressure value, I have taken this one. Okay, so it is clear, no problem. So maybe little bit different it is coming 0.0025 and here 0.01 is coming. I have taken the minimum value now for this one. So better is what? Just go for this value 0.02. Okay. So from here, you can just change it and take this value, the maximum one. As per that, whatever value you are getting. Okay. But here it is so, it is not coming exact as per software which I have shown you. Okay. That is why I'm telling better is now follow the software. Whatever value we are coming in software, follow that value. Because see, in software, it is different. 0.001 it is showing. Okay. As per this CFM. If you reduce, write down 489 CFM and let's see, check it. For 489, it is coming near about 0.00 something. Okay, so here remember the flow value which we have to take is always how much? After reducing whatever flow is coming, now that flow you have to consider. Don't need to consider the previous flow. Okay, 489. So how much we are getting here? By formula also same way, near software also you will get near about same value 0.0025. Correct? So it is depend on you what you want to use software or what. Clear this thing? Tell me please, all of you now. Is it clear? And in the previous reducer also, if you apply the formula now, see, by using the formula also we have got same. When you see M8 into L9 means velocity pressure into loss coefficient value. So see how much I have got 0.01 only. And in software also, which when substitute the value now, so same we have got. Okay, so remember this thing. Always remember the flow value you have to enter whatever you have got after reducing the duct. Okay, as per that, you have to enter that value. Okay, now come to next. See, Sadiq, what I am just discussing here, we are calculating the friction or pressure loss value in reducer because in our case, reducer is coming na. So first you have to substitute the, see, largest duct value means the width and height. W naught, H naught means before reducing what is the duct width and height. So in our case, when you see na in AutoCAD file, I'm talking about this reducer. Before reducing, W naught value is 400 mm, correct? And height is 300 mm. And after reducing, the height and width is 300 by 300, correct? And the reducer length is 450. I want to find out the pressure loss value. So simply, you can go for manual calculation or otherwise software. So software, when you enter this all value, flow value, remember, after reducing whatever you are getting. So it is coming 0.00 something. But in software, only you will get the value after decimal if it is only 2 point is given. Okay. So better is what? Go just manually here because just little bit very low friction loss is coming now. In our case, 0.0 C into PV, loss coefficient into velocity pressure. As per that, 0.025. Clear? Is it clear? Either it is big to small or small to big. Our main target is to enter the value. Okay. Don't need to go that, see this thing. Okay. Here you have to just understand the value. Main target is to what is your larger duct size and what, because see, we have to input that value and flow length and this value is needed here. Okay. Flow is either from small to big or big to small. So no problem. Okay. Come to next now, all of you. Let's see. After this reducer, when you see, again, we have a straight duct. And size of this straight duct is 300 by 300. Here I am using the DLI command to measure the length. So is 1.35 meter, correct? So I'm just writing here in Excel sheet. See all of you. Straight duct width is 300 and height is also 300. And now 1.4 near about meter we have got. As per that, how much friction loss value we have got? 0.01, 0.0115 manually. If you want to go for software, so same value you will get. See, come here in straight duct and enter the value. Let me know 12-inch height, 12-inch width because 300 by 300 and length is 1.4 meter. So can you convert that meter in feet? 4.5, na? 4.5, 4.6, whatever. Just take it. And flow, what is the flow? 489, I think. Hit on calculate. See, you will get that value. What is our flow value? Can you tell me in a straight duct? Okay, flow is 489. Okay, as per that, whatever value you will get. So in Excel sheet, manually also you can do or with the help of that software. Okay, now come to next one here. Actually here now our friction loss is very less. See 0.00 something. So it is. Now come here. Next, when you see in your AutoCAD, after this straight duct, see the elbow. This is very important. Let's see all of you how to calculate the friction loss value in elbow. Pressure loss or friction loss value. Now here 90-degree elbow is coming. So for that, simply just to find out the friction loss, just write down the length, width and height of that elbow. 300 width, height also 300, all of you know. And the total length. Now, how you will get the length of this elbow? So for that, we have a design criteria. I will explain you how to find out the length of elbow and how you will get the friction loss value, everything that we'll discuss. Because elbow is one type of fitting. So you have to use that formula, loss coefficient into velocity pressure. So first calculate the loss coefficient value. So by using the software. So here, okay. In a rectangular supply, where is supply here? See the elbow option is given. Okay. But come here in the common because we have see different types of elbow, meter elbow, other elbow, smooth radius elbow. So our main target is smooth radius elbow. Okay. Which type of elbow? Without van, you want to use one splitter van. So can you tell me anyone? I have already explained you how to do the selection of van. If your duct width is up to 500 mm, so one, how many number of splitter? One. So in our case, when you see our width of duct is 300. So single splitter van is enough. Na? Otherwise, without van option is given because our width is less than 500, means 300. So you can go for without van. So here, when you hit on smooth radius elbow without van, they will ask you to enter the width. So width is 12-inch, I have entered. Height is also 12-inch, 300. Now they will ask you for center line radius in inches. Center line radius means, see, this is your elbow. Just draw one line center and this radius, center line radius is needed. How to calculate this center line radius? And flow value is 489, correct? So to calculate the center line radius, all of you just listen carefully here. What you have to do here, see, one formula is given. Try to understand all of you. Different types of elbow is given. Short radius elbow, medium radius elbow, uh, and long radius elbow. Okay. So which type of elbow you are using in your project? So if you have, suppose if space is availability, okay, so go for long radius elbow is best. But let's say if you have little bit compact space, so we are just going for short or medium radius elbow, okay? So it is given here. To calculate, suppose let's say for example, I'm using long radius elbow and we need to calculate the center radius. See, this is R dash is your center radius value. So here the formula is written. To calculate the center radius, formula is what? R dash is equal to capital R plus width by 2. Capital R value from this point to this point, the radius. Okay. And whatever your duct width, suppose if your duct width is 3 feet, so 3 by 2. Okay. If it is a 400 mm, so 400 by 2, whatever width as per that. And radius, how much from where you will get this radius? Yes. See, it is given. It is depend on you which type of elbow you are using. Suppose, let's say, for example, if you are using long radius elbow, so to calculate the capital R value, simple. See, whatever your width is there now, 36-inch duct width, same is your radius. Okay. Understood, or will explain you in detail? Tell me. See, I will show you. In our case, how much center radius elbow we got. Okay. Each and everything we'll discuss here. So let's see all of you, my blackboard is visible. Please don't be keep quiet like this. Let me know, please. Blackboard is visible. Actually, why we are calculating the center radius? Because see, in software, if you want to calculate the pressure loss value in 90-degree elbow, so they will ask you about the center radius in inches. So to calculate the center radius, see, we have this type of elbow. Okay, I will show you the layout first. This is our elbow. Okay, and I'm assuming in our drawing, we have a long radius elbow like this. Okay, this type of elbow we have. And if you want to calculate the center radius, and what is the width of our elbow? 300 mm. Remember, okay, this thing. Height is also 300. So width is 300 W. And our main target is to calculate the center radius, this R dash value. So to calculate the center radius, R dash, here, you have to use the formula. First of all, just calculate this value from this point to this capital R value. Okay, plus width of duct divided by 2. So to calculate the capital R value, simple. What is your width? Same that you have to consider. Means capital R, in this case, the capital R value is 300 because our width of duct is 300. And then W by 2, 300 by 2. Can you tell me the value? 450 mm. But we need to enter the value in inches. So how much now in inches? 450 mm. Yes, fast. Let me know the value. 450 divided by 25 is how much? 18 inch. Am I right? Tell me. Or 18 inch. Yes. So just write down the center. I hope that all of you understood how to calculate. Okay. It's 18 inch. And flow is same. Angle 90-degree. Hit on enter. Calculate. So see, the pressure loss value is so small, means 0.00 something. That is why here the value is not showing, because in software, you can only see the value after decimal if you have two digits. So you can see that. Suppose if you have a 3 digits, so it is not visible. Okay. Okay, so no problem. We get this loss coefficient value, na 0.17. So as per that, just open the Excel sheet and do the calculation. 0. How much we have got? Tell me. 0.17 loss coefficient value. 0.17. See, where is your straight elbow? Here I am writing loss coefficient 0.17. Now our formula is, whatever your formula means, velocity pressure into loss coefficient. As per that, we are getting here 0, but change the flow value. I have not changed here. In a straight duct also we have 489. And here also in elbow flow is 489. Okay, see 0.0031 something. That is why it is not visible in software, because after decimal 3 digit is coming. Na? Remember this thing, okay? In this way, generally we have to calculate the pressure of friction loss value in elbow. Same way again, we have a straight duct. When you see after this elbow in our layout, see after the elbow, in our layout, when you see, again, we have a straight duct. Size is given here and flow value is also given. Okay. Don't be forget. DLI command. Length I need 2 meter. Okay. So just simple. Write down straight duct 300 by 300. Height also 300. And the total length is 2 meter. Flow value how much? 489, correct? I have written here 489. As per that, we have got in 100 feet of duct length, the friction loss should be 0.035. But our total length of duct is 6 feet, 6.5 feet. So if in 100 feet of duct length, the friction loss is 0.037. So can you tell me in 6.56 feet of duct length, friction loss is how much? Tell me, please. First, let me know your name, 89129. You're talking about this. All detail which I am showing is as per SMACNA ASHRAE book. You just, okay, as per ASHRAE or this value, what I'm, see the formula which I have shown from the ASHRAE handbook only, okay? So this all data you will get in that. Here we do not have that much of time to show you each and every reference from where we have taken, okay? So let me know, please. Suppose if in 100 feet of duct length, friction loss we have got 0.037. So let's see. Here I am showing how we get this value. When we have calculated the friction loss value in 100 feet of duct length, so how much we have got? 0. Friction loss value is 0.037. 0.037 inch of water column. But our duct length, when you see now, actual length of duct, straight duct length is how much? 6.56. So we need to calculate the friction loss for 6.56 feet of duct length. So how much? X. Just do the cross multiplication. You will get the X value 0.037 into 6.56 divided by 100. So same formula I have applied in the Excel sheet also. When you see now, same formula. To find out the friction loss for actual length of duct, same formula, see, P15 by into G15 divided by 100. Same formula I have applied here. So as per that, we have got 0.0024. Okay. So in this way, clear? Clear this thing? Now, when you see in your layout, now, again, we have a elbow. After this straight duct, again, we have a elbow. So same elbow and flow rate and everything is same. So already we have calculated also for that elbow. See, same value I'm writing 300 and 300. I think the length, sorry, here now we have to enter the flow value. How much? 489. Friction loss coefficient value we have calculated 0.17. Na? So as per that same we are getting here. But the value is little bit different here. Why? Velocity, pressure, friction loss is correct. Yeah, it is correct. 0.031. Here also we have getting 0.031. Now come to next one. After this elbow, again we have a straight duct. Okay. Can you see this is straight duct? Yes, please let me know. Yeah. I'm talking about here. Yeah, of course. Just wait. Tell me fast. See this from this point. Actually, problem is one. Na? Remember, here the flow is different. Here arrow is not given. So 1 minute, I will just draw the leader line so you will get the idea. Here the case is different. Okay. See, from this point to this shoe neck, I want the length because after that the flow will be different. You can see 172. Okay. And the duct size will also changing. Okay. So let me know fast. Please, can anyone? So simply just use the DLI command from this point to here. Up to here is enough. So see, but here problem is what na? If your duct height or duct width is reducing up to 750 mm, so it is, you can use it. Okay, no problem. Clear? But here I have taken same size. When you see na 50 mm, I don't need to show the reducer and everything for 50 mm. It is so small. That is why I'm telling. So just go for same value. Okay. Clear now? So here I'm what I'm doing. Just use the DLI command. Just measure the duct length up to here. Okay. 3.4 m, 6.4 meter. And size I'm considering this larger only, 300 by 300. Okay. But the actually problem is flow is also reducing now. Okay, so we have to measure up to here only. See, from this point is for a 3.8 meter, duct size is 300 and 300. Okay, so see what I am doing. Duct size is 300 by 300 and the width of duct total length is 3.8 or near about 4 meter, let's say. Flow is 489. Okay, so I'm just considering as per that whatever friction loss value you are getting, that value you have to consider. Same way, just copy one more straight duct, right click, first copy it, and here I want to insert, so insert copy itself. Correct. Again we have a straight duct, but their size is 250 by 250 and the total length, airflow is also different, total length is also different. You can see from this point, just DLI suppose from here to here. Length is suppose 2.5 and flow 172. Okay. 2.5, 172. Where is 2.5? Flow write down 172. 172. As per that, whatever friction loss value you have got. Okay. Then finally, when you see, here we have a, again, see, this is your rectangular duct and this is your flexible. It is in round shape. Okay, remember. So here we have to place one connector, rectangular to round connector. So how to calculate the friction loss value in this rectangular to a round connector? So that I will show you in software. We have that option. Okay. See, here in this software, duct mounted damper, even smooth radius, other different option is available. So come here in the round option. See, in supply round, transition, round to round, rectangular to round. See, rectangular to round transition. Just go for that. Okay. And just enter this input. So W1, WH1, do know, diameter. So can anyone tell me, please, how much we have got here in our case? When you see, tell me fast. See, this is our rectangular duct. The size is 250 by 250. After that, it is converted into round duct. So what is the diameter? So that all I will explain you here in Excel sheet. We can easily do. See, 250 by 250 height and width. Correct. So as per that, when you see now the diameter, equivalent diameter, we have got how much? 10.76. Okay. So that value we have to enter 250, 250, 10.76 in inches. In software, 250 means how much inches height? 10 inch. 10 inch by 10 inch. And the diameter, how much we have got? You can see already I have shown you in software, sorry, Excel sheet. When you enter now, how to convert that rectangular to a round duct, I have already explained you. Okay, what is the formula? So see, from that formula only, when you see now here, equivalent diameter is where? Here, 10.76 inches. Okay, 10.76 inches. Write down 10.76 inches. Length of that connector is how much in feet? So, okay, just measure it with the help of DLI command. See, easily we can measure here from this point to this point. See, 250 means 10 inch, correct? So here I am writing 10 inch. Is it clear? And flow value is how much? Tell me fast. 172, na? Flow value is 172 CFM. Finally, we have to supply to the last diffuser 172. Write down 172, hit on calculate. But here they are showing invalid or out of range input value. What we have done? Okay, actually problem is what? Not diameter value. We have entered 10.76. And here 250 by 250. Just enter the 10 only, okay? Why it is not showing? Acha, length value in inches. Sorry. The length of duct value we need in inches, na? So how much we have calculated here? 12 in here. It is 250. Okay, so it is also correct. In inches 10. So what we have not done here, correct? 250 mm means 10 inch only, na? Length also we have entered same. So, but they are showing table error, invalid or out of range input value. Why? Everything we have done as per. So why it is showing invalid? Suppose if I increase this one as a 12 inch by 2, so they will give you the value? No. Out of range. Why it is not showing? Transition, just a 1 minute, huh? Hit on full view and let's see. See, actually our main target H1 diameter value, okay, D naught W1 H1, okay, so everything is same. So why? Let's see if here actually what we have to do. Let's say I'm doing. Just increase the little bit length of the duct as a 20 feet or the connector, for example. Then also it is not showing. Na? See why? But if I increase the flow rate, for example, so problem is where here? I think the diameter value we have to reduce. Yeah, of course, then only. But in manual calculation, we are getting 10.76 for 250 by 250. When you see equivalent diameter, we are getting by using the formula only, na? See, everything is same. So as per that, we are getting. So, okay. No, length problem is not there. Actually, problem is what? Na, diameter. Diameter should always be less than width and width of the duct, okay? Take as a 9 meter, okay? But 9 meter is also not showing. When you are taking 8 meter, then only it is showing the value. What you can do, na? Yes, you are right, Sayed Kasim. In McVay duct sizes software, you can easily calculate. So see what I am doing. Just wait for it. Here I am opening that software so we can easily get the value. Okay. So here I have the McVay duct sizes software. So in that we can easily calculate, we get the diameter as per flow rate value. So can you see, all of you? Let me know. The software is visible. So how much CFM air we have? 172. I have entered the CFM air. Head loss, suppose let's say I'm using equal friction method, 0.08 inch of water column, 100 feet of length. So as per that, see, when you see now for this flow rate, and if you're maintaining 0.08 inch of water column per 100 feet of duct length, can you see the equivalent diameter is showing 7 point, how much? Tell me, 172 head loss right now. Suppose I'm going for 0.08. Normally, we are using the head loss value 0 points per 100 at every 100 feet of duct length. It is totally not depends on which type of based on your application for residential or for commercial or for industrial. Okay. So normally for commercial, we are maintaining the head loss value between 0.08 to 0.1 inch of. So in my case, when you enter the flow value and head loss value in software, so here the velocity and even the equivalent diameter is showing 7.5 inches. And by using that manual calculation, how much diameter we are getting? 10 point something. That is why the problem is coming in this software. Okay. So make sure the diameter value always you have to enter 8 inch is enough. Okay. 7 point near about 8 inch. Okay. So we are getting, see the pressure loss value is, I think it is so small. So no problem. Take the loss coefficient C1 value 0.25. Okay. And let's see here 0.25. So here I'm just entering 0.25. As per that, we'll get the friction loss value, but change the flow value first. One, how much flow? 172. This one also 172. As per that, whatever you are getting, 0.012. See, loss value. Finally, when you see now in our duct, finally, we have a straight circular duct. Okay. So everything is same, but remember the one point, suppose from year to year, 0.9 meter, then we have to drop the duct down also for suppose 1.5 meter total length I am considering. And see the diameter is 200. And flow value is also given near about 147 or sorry, 146 or 147, whatever you are getting that you have to consider. Okay. I think, sorry, acha. This one, this value is for diffuser. Okay. Remember, it is not correct. That is why we are facing problem. Actually, see, here it is given flow value 146 because see total from here 489 and when you are supplying 344 here, so 489 minus 344 is how much? 489 minus 344 is 145. Okay. So you have to consider the 146 or 145. Okay. Just change it. Okay. In Excel sheet, wherever you have written 172 now, write down 146. Okay. Is it clear? Tell me all of you understood. Now tell me, we have a straight duct whose diameter is given directly. Whose diameter is given. Okay. Value is C. Diameter is 200 mm. This flexible duct diameter. Okay. And length we have measure 1.5. So here what I can do, just remove this formula from here. Directly I am writing equivalent diameter 200 mm. In inches, how much? 200 mm means 8 inch, correct? I have written here 8 inch. As per that, whatever we are getting a flow value just 146. See, in 100 feet of duct length, we are getting 0. As per your total length, enter the length, please. 1.5 meter. So see, in 100 feet of duct length, friction loss 0.041, but for 5 feet of duct length 0.02. But remember, as I told you in flexible duct, the friction loss value should be 2 times greater than in normal duct. Na? So here same formula, I am just applying 2 into the value which you are getting. Okay. 0.02 into 2, 0.004. Okay. Now, finally, when you see in your software, sorry, in layout, now we have a air terminal. So here also, because I have already explained you external static pressure caused by duct work, air terminal device like diffuser. So in diffuser also little bit pressure. So from where we get this thing? So for the diffuser, here I have one software, or even if you have a manufacturer catalog, as per that, you will get each and everything. So here I have one software, beta software. Okay. See. Beta performance. This is one of the software for sizing air terminal device. Either it is a diffuser and whatever. So I hope this software is visible. Beta Industrial LLC. So here, come here, ceiling diffuser. Okay. Then in this ceiling diffuser, finally, for what purpose you are using diffuser? for supply, and unit system, let's say Imperial, because we are working in Imperial. And here the diffuser which we have, what is the size of this diffuser? 250 by 250 square diffuser. So shape is square, go for selecting data. Okay. Now what you have to do here, see one thing, remember all of you. So when you see na, just 1 minute, huh? Give me time. Here, software is visible now, all of you. Let me know, please. This beta software is visible or not? Simply what you have to do, see again, I am showing what you have to do here in this software. Simply now, here, just go back from here, back to main, and let's see. When you open the software now, so they will ask you this type of information. When you select the supplier, ceiling diffuser, or whatever, so they will ask you to enter some input data. Okay. See, here in this software, with the help of this beta software, you can also do the door grill sizing, ceiling diffuser sizing, even linear slot diffuser. Okay. So we are talking about ceiling diffuser. Select that ceiling diffuser value. And now, finally, you have to enter. For what purpose you are using diffuser? For supply, na? For supply conditioner, and unit is Imperial. Diffuser size is a square shape of diffuser, 255. So go for selecting data. Now here you will get the size. But to see the size of to see the value of diffuser and everything, problem is what? Here, can you see the size of diffuser is visible? So enter the maximum noise criteria 35 for commercial. You can go up to 45. And always as per ASHRAE, the velocity which we have to maintain for air terminal device 5. And what is the flow value? 146, correct? Am I right? 146. Hit on find nearest value. After entering this value, hit on find nearest. Now you will get the result, but here you have to change the high contrast setting. Okay. So that I will explain you. Simply in your desktop, what you have to do, see, I will show you my desktop so you will learn how to change the high contrast setting. Right click, personalize option you will get. So from here, you can see the high contrast setting option is given. Hit on that and on. We have to use the high contrast to see that value. Just wait for some time. Now, can you see? Here we have done the changes. Now, finally, when I'm opening that software, now you can easily view that. Tell me, please. Now it is visible, the duct size and everything. How much size of duct is showing here? See, 9 inch by 9 inch. 9 inch means how much? 9 into 25.4. It's near about 250, na? 228 point something means 250 by 250. And for that, you can see even the throw and everything. Our main target is to see this one, pressure loss value. How much? 0.022 inch of water gauge. Means in 250 by 250 diffuser, the pressure loss value is 0.022 inch of water gauge. Okay, 0.022 inch of water gauge. 225 near about is we have to select because some standard size of duct is available na, as I told you in starting also. Is it clear? So the value is what? One minute, huh? Now again you have to change the setting. Sorry, that high contrast setting we have to do the changes. See, huh? From here just off it. 0.022. Now see all of you, listen carefully. Here I'm writing directly now whatever pressure loss we have got in diffuser. 0.022. So where is the supply air diffuser? Their pressure loss value directly I am writing 0.022. Okay. As per that, see the total external static pressure Total external static pressure value we have got in water gauge 0.065. Okay, when you add this all, you will get 0.0, and in Pascal 16.12. And when we have to add the 20% extra for safety. So near about C, 19.34. And in inch of water gauge 0.065. Okay. So our proposed ESP 20 Pascal, correct? So in this way, generally, we have to do the calculation. We have to calculate the external static pressure calculation. Is it clear? Now someone is asking me, so what about plenum box? Let's say, so everything option is available here. Okay, don't be confused. See, if you have a plenum box, no problem, come here and let's see. Plenum rectangular. See, the plenum option is given. Just go for that. See, different types of plenum. Conical bell mouse, sudden contraction, plenum to rectangle. So simple. Just go through you have to enter this input value. They will give you the pressure loss value. Same way, if you have a damper, different types of dampers are there. You know that, like whatever type of damper you are using. So in volume control damper also, we have a losses. So here we have that option also. Okay. Each and every option is available. So in this way, generally, we have to perform the heat we have to do the external static pressure calculation. I hope all of you get these things. Okay. So now, as I promised with you in starting that we have some special offer today. Okay. Only for those students who are in this webinar. The offer is what? Today, we have launched a complete HVAC course package. Okay. In that, you will get the HVAC designing pre-recorded course I'm talking about. Because we know that many of you are working professional. Okay. You are not getting that much of time for live class. So that is why we have launched a complete one package. Okay. HVAC package course, pre-recorded course. In that, you will get the complete HVAC designing course, pre-recorded course, even HVAC drafting, and you also get the HVAC equipment selection course. So 3 courses you will get in one package. Okay. So here, only for this webinar student, we have some special discount for that course. You will get that course only in 4,999 rupees. Means only in $75. This is a special discount, and this discount is only for last 20 minutes. Remember this thing, okay? You will get the complete 3 courses in one package only in 4,999 rupees in $75. So if you are interested for that course, I will show you each and everything, what syllabus, what topics we are going to cover, that all will share you. But let's say if anyone are interested to enroll that course, so simply here I am sharing the payment link, both INR also, even USD payment link, both link I will share you. You can just use that link to enroll in this course. Okay. Now the question is that, sir, which topic you are going to cover in this complete pre-recorded course in this package, what I have shown you now. So that all will explain you in detail. When you see in your website also, you can visit our website. So in that also you will get, but problem is what na? The regular fees of that course is different. I will show you in website. Okay. So just you have only 20 minutes. Okay, to enroll in this course for this offer. And let's say if you have any question or need further assistance, so you have to contact into the given WhatsApp number, which I have shared in the chat box. All of you see, okay? In the chat box, already I have also shared the payment link. If you are from India, so use the INR payment link or otherwise USD payment link, correct? To enroll in this course. Only in $75 you will get this course, okay? Means 4,909. So now when you see in our website, if you visit and now see what syllabus we are going to cover. See, this is our HVAC design complete course, because here I have one package. In that we are also giving you the HVAC design complete course plus HVAC drafting course, HVAC equipment selection. 3 course we are giving in one package and only in 4,999 rupees, $75. Can you see? Already here we have a HVAC complete designing course. And in that already 5 rating is also given. Already 674 students have enrolled in this course. What, see the regular price right now, it is offer we have given, Diwali offer, 499, 4,999. Only the HVAC design course is 4,090 regular fees. You will get the enrollment validity is also given here, 1,000 day. Even what you will get here, total duration is 21 hours, 51 minutes. I'm talking about only for HVAC design course, okay, right now. 21 hours, 51 minutes. Certificate of completion also you will get. Even the material, 21 plus hour video lecture, international recognized certificate of completion, 200 plus interview practice question, ebook, Excel sheet, 100-day access. Now, same way when you see HVAC drafting course, see, and their regular price is 3,990. Actually, this is separate course, okay? In AutoCAD software, HVAC drafting project, we have completed the one hotel building, high-rise building. So the course is of 3,999. And you can see the duration is given here, 8 hours, 24 minutes. Okay, certificate also here also you will get. Here, whatever software we are using, like MacWay Duct Sizer software, fitting software, everything you will get. Okay, clear this thing? Even see, when you see the next HVAC equipment selection, in that the regular price of this is 9,999 rupees. Okay, regular price. But we are giving this 3 course in one package and only in 4,999 rupees, means only $75. So this is the best opportunity for those students who, who have wanted to learn the complete HVAC designing and drafting course. Okay. So if you are interested, so I have already sent you the both link in INR, payment link also USD. Yeah, this all, yes, of course, we'll give you the setup, Ahmed. Everything, the software which we are using, na MacWay, even Azure data fitting, beta software, and many other software is there, okay? So you can easily download that software, okay? Only you will get the access for video recording. Material you can easily download, Excel sheet, PDF file, whatever will share, okay? And next thing, as I promised with you, all of you, that will also give you the recording access link in the end of the class. So I am sharing the this webinar recording access link in the chat box. All of you can use that link. Okay, remember you will get the when you hit on this link na, they will ask you for request. Okay, so don't worry, after 1 hour, we'll also give you the access request access. Okay, we'll upload we'll give you. Okay, next thing, for the certificate of completion, what you have to do, again, see your chat box. You have to mail it into the given. See, I have shared one email. You have to mail it for certificate. Correct? Is it clear, all of you? So what you have to do, is it clear? So now the next thing is what? If anyone are interested, so please use the payment link which I have shared. And let's say if you're facing any problem for course enrollment, so you can contact into the given WhatsApp number. Okay. See, I have also, I'm sharing the WhatsApp number. You can contact easily into the WhatsApp number. And now if anyone have doubt, okay, now maybe many of you are just thinking that what topic we are going to cover. So see, I am showing that also, the syllabus. All of you just listen carefully here. See, all of you. No, and remember, again, I'm repeating. This offer is only for last 20 minutes. Okay. After that, you will get same this course. I think in 20,000 rupees, this 3 course, near about 25 or 20,000. Okay. So that is why I'm telling this is the best option for you. See, the topic which we are going to cover in our complete HVAC design course, which type of topic? First, you will get the introduction to the HV psychometry, even load calculation will show you by using the E20 method in detail. Even by using the HAB software, you will get the load calculation, duct system design, everything we'll discuss here. See, each and everything, fan selection will see, air filters designing selection, air terminal designing selection, diffuser, grill, how to select, find out the capacity of air handling unit, coil selection, FCU selection, okay? Their working ventilation system, in that we have to discuss, we'll discuss all car parking, toilet, each and every things, okay? Someone is telling me, sir, link have do not access. So don't worry about Babar. We'll give you the request access after 1 hours, okay? Because right now I have not uploaded that recording. Na? We'll give you the access after 1 hour. So don't be just confused. Okay, all of you. So see, even smoke management system also we have to discuss in the recorded class. Stairway pressurization system, cooling equipment and component, even HVAC system. No one will give you this complete course in detail only in 4,999 rupees. Okay, means $75. See, we have also discussed in detail about the VAV system, VRF, VRV system, chiller system, pump selection, booster pump selection, chiller piping, everything. Okay. Now see, again, I'm sharing, maybe someone are confusing. So see, what link you have to use for this course. See, I'm sharing again the payment link. All of you just, you have to use this link, okay? To get this offer, if you want this package, this HVAC course bundle in 4,999 rupees in $75. So you have to use this payment link, which I have shared. So I am sharing Al Kasab. I am sharing one WhatsApp number. That is why I have told you that if you have any question or need further assistance, so for that, here I am sharing, see, one WhatsApp number. So you can just contact into the given WhatsApp number. Correct? No, this offer course which I'm just selling here is pre-recorded course, okay? It is a pre-recorded course. You will get the access for 1,000 days. Okay, it is a complete recorded course. Remember. And second thing, someone is access, whatever I have already shared the recording webinar, recording access link to you. So you will get the access after 1 hour. So don't worry about that. Okay, all of you. Again, I am sharing that. See, in chat box, I have shared that. Okay, see, here I have discussed for the HVAC design. Same way when you come here in the HVAC drafting project course, that also included in bundle, in package. So in what we are going to cover here, first I will explain you about the overview HVAC system, their component, even then introduction to CAD software, okay, basic tools and command which we are using in HVAC drafting, that topic we have to cover. Then about the common symbol used in HVAC, okay, then heat load calculation, placement, how to place the air terminal device, either the grills, diffuser, whatever, ductwork design, how to find out the size of duct, and everything we'll discuss here, okay? Even see the HVAC schematic layout, how to draw that also, how to create the sheet and title box, that also we are going to cover. I have paid for the course. Now how can, so ZR, I don't know your name. You will get the access. If anyone have enrolled in our course, so you will get the access after 24 hours. Okay, so don't worry about that. We'll give you this detail. Don't just worry. After 24 hours, you will get the access. the course which you have buy from our site. Okay, clear? See, these are the things. Yeah, of course, you will get the separate. It is depend on you. If you want separate certificate, Imran, you will get the separate also. Don't worry. What about estimation part? That also we have discussed na in designing. When you see na here, we'll also cover that also. You will get. Even see in HVAC equipment selection, what we have discussed. See in detail. Here, the selection of air handling unit means sizing and selection of air handling unit. Even we'll also discuss about the sizing and selection of fan coil unit, chiller selection, cooling tower selection, treated TFA selection, treated fresh air handling unit, sizing and selection, fresh air handling unit, how to size and select coil selection, dehumidifier, humidifier selection. These all we are going to cover in your package. You will get this all details. See, here, the regular price only for this course is 9,099 rupees, but we are offering the 3 course in one package only in 4,909. But this offer is only for last 10 minutes because 10 minutes is remaining. Okay. If anyone are interested, so please hurry up and do fast. Okay. You have only 10 minutes to enroll in this course. Okay. Again, I have shared the link, payment link. You can use this link, and after the enrollment, you will get the access after 24 hours. What is difficult, Prakash, here? Uh, you cannot able to, you cannot able to get the enrollment. Yes, tell me. So I am sharing the WhatsApp number also, na here. Contact into the given WhatsApp number. You can easily get everything. Okay, Prakash. I have shared the WhatsApp number here. If you have any question or need further assistance. No, sorry, Excel and PPT you will not get. Okay. Only will share you the webinar recorded access link. Notes you have to prepare. Otherwise, what you will do? Okay. For this session, see, Tejas, for this session, if you want, because you have participated na, for this session, the webinar. So if you want the certification of participant, so what you have to do, just email it in the given WhatsApp number. In group, I have shared. Okay. So last 10 minutes are there for this offer. If anyone are interested, so just enroll it fast. You have last 20 minutes, 10 minutes only. Do it fast. And if anyone have confusion and any queries, so you can contact into the given WhatsApp number, which I have already shared in the chat box. Okay, Tejas. So if you have enrolled the course, so don't worry, you will get the access after for 24 hours. Okay. So don't worry about that. And I hope that all of you are enjoying the course. All of you have enjoyed the course. Okay. So these all in detail we have discussed in this course. So that is why I'm telling this is the best opportunity. Don't think so much. Okay. Yeah. So for that, Tejas, you have to email into the given WhatsApp that mail I have sent one. Can you see for certification of completion? You have to mail it into the given. Yeah, that I have shared now already in the chat box. See, for certification of completion, email augmintech@gmail.com. You will get the certificate of completion. Okay. Is it clear, everyone? Okay. So last 8 minutes are remaining. So just hurry up and do it fast. If anyone are interested, don't think so much. Okay. Fast. Can you share? Yeah, Akshay, I have already shared you. See the recorded webinar access link I have shared in the chat box. Na? How many times I will share? You will get the access after 1 hour for this webinar. Okay. Again, I'm sharing. See in your chat box, all of you see. Uh, yeah, this webinar recording access link. I have shared. Okay. We'll give you the access after 1 hour. Just go through. Okay. So last 6 minutes is remaining. All of you do it fast. If anyone are interested, don't think so much. Just enroll it fast. And if anyone are facing any problem, so let me know. Akshay Rajan, I have already explained you. After 1 hour, you will get the access. Now, why you are just confused? No, Excel sheet will not provide you. Only recording you will get. Okay. Yes, last 5 minutes are there. If anyone is interested, please enroll it fast. After that same course, you will get, I think, near about, you have to pay it. If you want this three course na separate, so you have to pay it, I think, 20,000 rupees you need to pay. Means near about $300. So today for this course you will get only for $75. Okay, so for that na Prakash, I am sharing one WhatsApp number here. You just contact into the given WhatsApp number. Yes. Anyone have any question regarding the enrollment? Anyone are facing any, suppose let's say if someone are facing problem, so let me know, please. I'm available. Okay. Last 5 minutes is remaining. Please do it fast if anyone are interested. Again, last time I'm sharing the link. Again, both. If anyone are interested, so do it fast, okay? Otherwise, this offer will be closed after 5 minutes. See, Again and again, ZR, I have already shared the WhatsApp number if you have any question or need further assistance. So see in your group, I think you are not active in this group. That is why you are facing problem. See, many of the students are enrolling the course like Kasab, and many students have enrolled already. So don't think so much. See, it is given. You will get the access. You can access the course content through Augmintech website in 24 hours if you have enrolled the course. Okay, so don't worry. Yes, fast. Yes, anyone have doubt regarding enrollment process? Yes, last 5 minutes is there. Okay, after that we'll close this offer. See, for course syllabus now, what topic we are going to cover. Here in front of screen it is given, or even you can visit our website also, augmintech.com. There also you can get the complete detail. Even here also I have shown already, okay, what topic we are going to cover. You can see already I have discussed that. Okay, you will get the access for total 1000. See, enrollment validity is given here 1000 days. Even the duration, I think if you combined all the course, I think total course duration is near about 40 plus 40 hours. Okay, and lots of interview practice question, even the Excel sheet, whatever we are using, software setup file, all this you will get. Okay, so no one will give you the course only in the $75. So please, if you are interested, so go for that. Now last 2 minutes is remaining. Okay, if anyone are interested, so do it fast. Last 2 minutes remaining. After that, we'll close this offer. Last 1 minute is remaining. Now again, I am just sharing that recording access link. Okay, and you will get the access after 1 hours. Okay, so don't be confused. So if anyone have not used, just select, click on that link. You will get the access after 1 hours. Okay, is it clear? So hope now I think offer time is end. Okay, all of you. Now, finally, hope all of you enjoy this session. So see you in next one. Goodbye, all of you. See you. And thank you to this webinar.